This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is video 11 in our series on solving equations with decimals, and we're going to do this problem on this video where we have more than one term on each side. Again, there's more than one way to solve practically every equation, and that's true of this one as well. What you could do is leave everything with the decimals as is and get the variables on one side and constants on the other. Now I notice 7.2 is larger than 5.6, so I'm actually going to put the variables on the right by subtracting 5.6x from both sides so that I have a positive number for the coefficient of x. All right, so if I do that, and I have the variables on the right side, I want to add 6.4 to both sides. So let me move this over so we have a little bit more space to do that. I could show the plus 6.4 at the same time, and I'll just put that over here. So I'm adding a 6.4 and a negative 5.6x to both sides. So I'm just leaving it. I'm not worrying about that there's decimals in the problem at all, and I'm just putting the variables on one side, constants on the other. So that would give me, on this left-hand side, 6.4 equals, and I think that's 1.6x. Now, if you did it the other way, you'd have to do 5.6 minus 7.2. It's harder to do that arithmetic in your head. You have to, go off to the side and do it. So that was the reason I did it this way, to have a smaller number subtracted from a bigger number. All right, now we're going to have to solve for x. Again, we could just divide both sides by the coefficient of x, and that's 1.6. And so I have to do 64 divided by 1.6. So the first thing you might notice is you have a decimal still in the denominator, and you want whole numbers in the denominator. So if I multiply the denominator by 10, it means I move the decimal one to the right, but then I have to multiply the numerator by 10 as well. So that really becomes 64 over 16. Equals x, and that actually equals 4. 64 divided by 16 is 4. So I could write x equals 4. So that's one way to solve it. You just take your problem and solve it, not worrying about there's decimals, and at the end of the problem, when you have to start, well, actually right away, you have to use your rules for adding and subtracting with decimals, and then later with dividing by decimals. That's fine. The other way to do it is you can eliminate all the decimals in step 1, similar to how when we eliminated all the fractions in an equation. So here's the problem again. Since you see there are decimals in this problem, if you want, you could multiply both sides by the least common denominator, which is really 10. So in other words, you need to move the decimal 1 to the right. I'm thinking of this as 56/10. That's why I said least common denominator. Okay, so if I multiply this by 10, then I'll be able to move all of the decimals 1 to the right. If there was a number like 6.41, I would want to multiply it by 100 so I could move this one 2 spaces to the right. But the most digits after any decimal point here is 1 place, so you multiply 1 with 1 0, which is the number 10. And that means I'm distributing 10 to each number on both sides. And when you do that, it's going to move all the decimals 1 to the right. So you can show that step if you want. Say I'm multiplying each term by 10. Okay? That's up to you. And so I have, So now when I have 10 times 5.6, that's 56. And then I have times x. This gives me 72. And that gives me 64. And so now you have an equation without fractions, and then you could proceed. So I would solve this pretty much the same way I did the last one. It's just that I don't have any decimals involved. Now let's go ahead and put the variables on the left this side just to see that it doesn't matter. If you do that, we're going to have negative 16x equals negative 64. So that's what happened if you put the variables on the left hand side and then we divide both sides by negative 16, right? Because you want the negatives to cancel as well. So our answer is 4. All right, so we've done this problem 2 times. Both times we got 4. So let's go ahead and check it. Looks like a pretty good bet that must be the right answer. So we're going to check x equals 4 into the original problem. Make sure you check it in the original problem, because if you check it in some other step, you might have made a mistake and you won't catch it. Okay, so we're going to plug in 4 for x. So we have 5.6 times 4 on the left-hand side. So we have to do 5.6 times 4. Now, you can get out your calculator and do that, or you can do some arithmetic to the side, but make sure that you multiply that 56 times 4 and move the decimal point in one place, and what do you get? I get 22.4. All right, so that's after you do that arithmetic. All right, now let's do the right-hand side. You're going to do 7.2, putting a 4 in for x here. Right, same thing. You've got to do your multiplication, 7.2 times 4, either with a calculator or longhand. I think that's 2.88. The way I do multiplying by 4 is I double the number twice, basically. So I think 72 doubled is 144, and then I double that, I get 288. So that's how I figured that out, by the way. So that's going to give me 228, but I got to move the decimal point in one. Then I'm going to subtract the 6.4. All right. And I said 288, but wrote 228, sorry. 288. And then when we subtract 6.4, you could go over on the side and do that as well, lining up your decimals. You do get 22.4. So x equals 4 does check. So that's the correct answer. And writing the answer using solution set notation, you put 4 in the braces. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.